Hello, we're going to do an exam review today. And so this is a review for your exam, which is going to be on July 3rd. So it's going to be Monday. So let's look at the first one. It says the following reaction is an example of what type of reaction. So if I look at the reaction, it says nitrogen plus hydrogen yields ammonia. So I have nitrogen combining with hydrogen to form ammonia. So I have two simpler atoms or molecules combining to form one. And so that is a definition of a combination reaction. So A is the correct answer. Next one, which of the following compounds is a weak electrolyte? And so for the weak electrolyte, that means it dissociates in water but doesn't dissociate completely. So if I look at it, I have HNO3, NaNO3, HNO2, NaNO2, and sodium hydroxide. And so I know anything that's ionic is going to be a strong electrolyte. It's going to separate out into its ions. And so all those with sodium in them are going to be strong electrolytes. And so that leaves nitric acid and nitrous acid. Okay, they're both, so these two have just nonmetals. All the other ones are metal, nonmetal. So I knew they were ionic. So these have nonmetals, HNO3, HNO2. So now it comes down to strong acid and weak acid. Okay, and so remember I told you you had to memorize those 6 strong acids. So if you memorize those, you know HNO3 is a strong acid. So a strong acid, 100% dissociation. And so the weak acid must be my weak electrolyte. So C, correct answer. Next one is, which of the following compounds is a non-electrolyte? So same process here. Okay, if it has a metal and non-metal, it's going to be a strong electrolyte, dissociate completely. So I know it can't be those two. Okay, now the other ones, here I have a strong acid, HNO3, and I have a weak acid, acetic acid. Well, those are both acidic, so a strong acid, 100% dissociation. So it'd be a strong electrolyte. Here, weak acid, so weak electrolyte. And so it still dissociates. So this is non-electrolyte. It doesn't split apart at all. And so that'd be the non-metals here that are not acidic. So glucose, correct answer. Identify the major ionic species present in aqueous solution of sodium carbonate. And so I know it's ionic compound, so it dissociates completely. So this is made up of sodium ions and then carbonate. So the polyatomic ion stays together and has a charge. So when it dissociates, you have your polyatomic ion and then your metal ion. And so E is the correct answer. You wouldn't write down Na2 like shown in this first one here. You'd have 2 sodiums, that'd be the coefficient in front of it, not superscript. Based on the solubility rules, which one of the following compounds should be insoluble in water? So you go down to the back page of your exam, you see some solubility rules. You know that anything that's group 1 is soluble. So sodium is group 1. So I know sodium chloride is soluble. Now these other ones are group 1. All the counter ions there, the anions, are bromides or chlorides. So if I look at bromides and chlorides in solubility rules, it'll state that chlorides and bromides are generally soluble unless it's silver, mercury, or lead. So if I look at this list here, I have one that's silver. So silver bromide would be one that's insoluble in water. Based on the solubility rules, Which of the following will occur when the solution containing 0.1 grams of lead nitrate is mixed with a solution containing 0.1 grams of potassium iodide in 100 milliliters? So really those numbers don't mean anything in this case. You're mixing the two solutions together. You want to know if it's a double displacement reaction, if they form a solid. So I have PbNO3, the aqueous solution, Ki. So I know nitrate NO3 has a minus charge, so I have two of them, so that must be a 2 plus. I know I is a minus and K is a plus. So if I take the positive my first, or the negative my second, I'll have the lead, the iodide. Iodide has a minus 1, lead has a 2 plus, so I need two of the iodides. So PbI2. And then take my positive, my second, or the negative for the first, so KNO3. I want to see if either of those are soluble or insoluble. And so PbI2, look at solubility rules. Iodides, generally soluble unless it's silver, mercury, or lead. So I have lead here, so that is soluble. That's insoluble. It forms a solid. Potassium nitrate, group 1, that's soluble, so it's dissolved in water. So when it's dissolved in water, it means it separates out into its ions. So this one does not dissolve in water, so it precipitates out of solution. So I see a precipitate in the solution. So KNO3 will precipitate? No. KNO3 soluble. No precipitate will form? No. Lead iodide forms. PbNO3 will precipitate? No. That's one of your starting materials. PbI2 will precipitate? Yes. K and NO3 are spectator ions? Yes, because the K and NO3s will be on both sides when it separates out into its ions. So D, correct answer. The common constituent in all acid solutions, and this is this definition of an acid, Arrhenius definition, substance that forms H plus in solution, forms your hydrogen ion. So H plus, correct answer. What is the chemical formula of the salt produced by the neutralization of hydrobromic acid with magnesium hydroxide? So hydrobromic acid plus magnesium hydroxide. So magnesium's a 2 plus, hydroxide's a minus. And so I need 2 hydroxides to balance out the 2 plus and be NaOH2. Now if I form the double displacement from this reaction, positive my first, or the negative the second, that's where I get my water, H2O, plus a positive my second, or the negative the first, so I have magnesium, which is a 2 plus, bromide, which is a minus, so I need 2 bromines to balance the magnesium, so MgBr2. So it asks for the salt that's formed, so magnesium bromide would be the salt that's formed. Oxidation number of nitrogen in NaNO3. So I know Na is group 1, so it's a plus 1. Oxygen's a 2 minus, and I have 3 of them, so 3 times 2 minus would be minus 6. I know the charge is going to be 0, so 1 plus what minus 6 would be 0. That'd be 5. So the oxidation number for nitrogen must be plus 5. So it says in the following redox reaction, which element is oxidized and which is reduced? So I know immediately this is an oxidation reduction reaction because I see nitrogen by itself here, so it's 0 there. And here it's in a compound, so it's not 0. And so I know something's happened to the nitrogen. So if I look at this, there's one of those choices that does not have nitrogen involved in it, so I can eliminate that one. So let's look at oxidation numbers now. I know nitrogen, let's look at NH3. So I know H is a +1, and I have 3 of them. So that gives me a 3+. So what plus 3 is going to be 0 minus 3. So if I look at nitrogen, it's going from -3 to 0. Any element's elemental state is going to be 0. And so -3 to 0, that means it has extra electrons here. It's going to neutral, so it's losing electrons. Leo, the line goes Ger, so loss of electrons is oxidation. Okay. And so I know nitrogen is oxidized. So that leaves chlorine and oxygen. Let's look at chlorine and see if chlorine changes. So here I have calcium, chlorine, and oxygen. I know calcium's a 2+, oxygen is a 2-, and I have 2 of them. So if I look at this, I have 2 chlorines as well, so I have to say 2 times something. So I have oxygen's a 4-, I have a 2+ here, so I need what? 2 plus 2 minus 4 would be 0. And so since it's 2 times something, so it must be +1. Over here, calcium chloride, calcium's a 2+, chlorine then must be a -. So I have chlorine going from a +1 to a -1. So it's deficient electrons, gaining electrons to go to -1, it has an excess now. So a gain of electrons is reduction. If you look at water, both of them oxygen, both of them oxygen is 2-, so it stays the same. So it's this one here, nitrogen is oxidized, chlorine is reduced. Okay, 11. Predict the products of the following single replacement reaction. So single replacement, so my metals are going to change positions. So here's, that's going to be it. The iron's taking the place of the copper. Let's check out the other ones just in case. No, that's not showing anything replacing it. I'm not sure where the sulfur's coming from. They're not all combining together. And then, that takes away an oxygen. So only A's, you're showing your single replacement. Look at 12. What is the molarity of a solution that contains 4.5 grams of potassium hydroxide and 500 milliliters of solution? So I have 4.5 grams. So you have to know what potassium hydroxide is. So you have to know hydroxide's OH-, potassium's K+, and so the plus and the minus cancel each other out, so it's just KOH. Just need one of each. I need to find the molar mass of that, and looks like I forgot my periodic table, so I might have to pull one up. So potassium is 39.1. And so I take 39.1 plus 16 plus 1, so 56.1. So 56.1, so 4.5 divided by 56.1. I put it on bottom using the molar mass here. Put it on bottom so the grams will cancel out, and I'll be left my number of moles. It says what's the molarity? Remember that molarity is moles per liter, so that's why I need the number of moles. So 4.5 divided by 56.1 at 0.08. And in 500 milliliters of solution, so that'd be 0.5 liters. Remember, molarity is moles per liter. So 0.16 molar. So B, correct answer. And this has 3 significant figures, 4 significant figures, so 3 significant figures in my answer. So looks next for solutions of calcium chloride and sodium carbonate are mixed in a white solid form. What's the net ionic equation for this reaction? So calcium chloride plus sodium carbonate. So I'm going to look at the ions here. So I know calcium forms 2 plus ions, chlorine minus ions. Sodium plus 1. Carbonate is a 2 minus. You didn't remember that. I mean, you get from, sodium's a plus 1, so it has to be a 2 minus to balance it out. So I take the plus from the first one, pair it with the negative of my second. So it's a 2 plus and a 2 minus, so they already balance each other out. And so I just need one of each. Sodium chloride, okay, they balance each other out as well, so NaCl. Now I have to go to solubility rules. Sodium chloride, that's group 1, I know it's soluble. So carbonates, if you look at carbonates in your solubility rules, most carbonates are insoluble unless it's group 1, so calcium is group 2, so it's not going to be soluble. And so that's going to be my precipitate that forms, that's your white solid that forms. And so the net ionic equation will be showing the 2 ions that come together to form your insoluble precipitate. So your calcium ion plus your carbonate ion forming your calcium carbonate. So E, correct answer. If I look at 14, which of the following represents a combustion reaction? Combustion reaction, I know the products are always carbon dioxide and water. Only one of those fit that. And so it's burning up hydrocarbon in the presence of oxygen to yield carbon dioxide and water. What mass of potassium carbonate is needed to prepare 200 milliliters of solution to have a potassium ion concentration of 0.15 molar. So let's go ahead and work this out. So where do I start? So I want 200 milliliters, and I want potassium ion concentration of 0.15 molar. So let's start there. So I want 200 milliliters of solution, so I'm going to go ahead and convert that to liters. So divide by 1,000.2. So I'm going to first find how many moles I would need then. So 0.15 moles. So when I do this, it says, no, it doesn't say a solution having a concentration of 0.15 molar. It says having a potassium ion concentration of 0.15 molar. So I'm looking for 0.15 moles per liter of K plus. Now I know 1 mole of K2CO3, okay, since it's K2, if that broke apart, it's going to form 2 potassium ions, since it's K2. So 1 mole of K2CO3 has 2 moles of K plus. And I did that because it says I have a mass of K2CO3, so I need moles of K2CO3, so I can use this molar mass, so 138.2 grams per mole. Moles cancel out, I'll be left with my answer in grams. So 0.2 times 0.15 times 138.2 divided by 2. So I get 2.073. So what would throw a lot of people off there would be probably not doing this step, since they asked for potassium ion concentration and getting A as the correct answer, right? But D is your correct answer. Look at 16. A 50 milliliter sample of 0.436 molar ammonium nitrate is diluted with water to a total volume of 250 milliliters. What's the ammonium nitrate concentration in the resulting solution? So I can just use the dilution equation here. I'm just adding water, so the number of moles is not changing. And it's all ammonium nitrate, so I can use this. Is okay using this equation. So my molarity is 0.436 molar. My volume of that concentrated solution is 50 milliliters. I want to find my molarity of my dilute solution if I add enough water to make a total volume of 250 milliliters. Solve for molarity of your dilute solution. Your milliliters will cancel out. You'll be left with your answer in moles per liter, so molarity. So 0.436 times 50 divided by 250. So 0.0872, which is going to be 8.72 times 10 to the minus second. So D, correct answer. (17) 34.62 milliliters of 0.1510 molar sodium hydroxide would need to neutralize 50 milliliters of the sulfuric acid solution. What's the concentration of the original sulfuric acid solution? So I'm going to start with the number that I know both the volume and molarity of. If I know the volume and molarity, I can get the moles there. So I'm going to start with these two numbers. Now I also, to go from one compound to another compound, need the number of moles. So I need the mole ratio for my balanced equation, so I have to write that out. So sodium hydroxide plus sulfuric acid. Okay, so I show its ions are formed. So take the positive in my first, pair with the negative the second, sulfate's a 2 minus, paired with the sodium, so +1. So I need 2 of them to balance it out, so Na2SO4. Then positive my second, negative the first, so there's my water. So now I need to balance that out. I have 2 sodiums on that side, so I need 2 sodiums over here. That gives me a total of 4 hydrogens, so I need 4 hydrogens on this side. Now oxygens, 6 oxygens on both sides, 1 sulfur, so now it's balanced. So like I said, I'm going to start out here, and I'm going to go ahead and convert this to liters. Now you can do that in a separate step, divide it by 1,000 or add a step to your conversion. I'm just going to move my decimal point in 3 places. So 0.03462 liters, and I know the concentration here is 0.151 moles of sodium hydroxide per liter. So that gives me my moles of HCl. So now I need to know my moles of my sulfuric acid. Now I'm asked for concentration. I know a volume of it, so I need the number of moles. If I have the number of moles, I can find moles per liter. So I need moles of sulfuric acid. So balanced equation time. 2 moles sodium hydroxide react with 1 mole of H2SO4. 0.03462 times 0.151 divided by 2 . Now that's my moles of H2SO4. I know my concentration, or my volume, was 50 milliliters, so I'll change that to liters to 0.05. So then that would give me moles per liter, my molarity. So divide that by 0.05. I get 0.052, 0.0523. To 3 significant figures, which I have 4 here, 3 here, 4 here, so I go with 3. So C, correct answer. What mass of lithium fluoride is needed to make 250 milliliters of a 1.5 molar solution? So I'm going to use my molarity as a conversion factor. So where do I start? I'm going to start here where I have a volume in my concentration. So for my volume and concentration, I can find the number of moles. So again, I'm going to move the decimal point here 3 places so I can say liters. 1.5 molar solution, so 1.5 moles of lithium fluoride per liter. That's the concentration I'm looking for. And now I'm given the molar mass there. It says what mass, so I want mass now. So 25.94 grams of lithium chloride per mole of lithium chloride. So notice how I put the grams on top, so my moles would be on bottom and cancel. So if I calculate that out, 0.25 times 1.5 times 25.94, get 9.73, the three significant figures. I need 3. So D, correct answer. Was the minimum volume of 0.075 molar sodium hydroxide needed to neutralize 10 milliliters of 0.035 molar sulfuric acid solution. And so, same balanced equation that I used before. So again, we're going to positive my first, pair with the negative the second. I have a 2 minus here, so I need 2 sodium, so we need 2 SO4. Then I have my water. Balance it, I need 2 sodiums. I had 2 sodiums here. That gives me 4 hydrogens. I need 4 hydrogens over here. Oxygen's balanced, sulfur balanced. That's my balanced equation. Okay, so where did I start? Here now. I'm going to start with what I have a volume and concentration of. And again, I'm going to go ahead and write out in liters. So I'll move my decimal point 3 places. So it's 0.035 moles of H2SO4 per liter. So that gives me the number of moles of H2SO4 I need. So now I need to go to my balanced equation. I will go from H2SO4 to sodium hydroxide. So balanced equation, moles of H2SO4 is on top here, so I need it on bottom here. 1 mole of H2SO4 requires 2 moles of sodium hydroxide. To neutralize it. So that gives me my moles of sodium hydroxide. Now it says what's the minimum volume of this concentration of sodium chloride I would need. So I've got moles, so I need to know, well, how much of this would give me that number of moles. So I'm going to use this as a conversion factor. This time I'll go on bottom because I want the moles of NaOH to cancel out. So 0.075 moles of sodium hydroxide in liters of that solution. 0.01 times 0.035 times 2 divided by 0.075 so 2 significant figures. So 0.0093 liters, and if I put that, all these answers are milliliters, so move the decimal point 3 places, 9.3 milliliters, correct answer. So again, you'll be tempted to use the dilution equation on this, okay, because you have like one concentration, then you have a volume and a concentration down here, so you try to plug in that equation, you get the wrong answer, because it's not 1-to-1. You're going from one compound to another compound, so it won't work here. Last question. What volume of 0.3 molar hydrochloric acid must be used to react completely with 4 grams of zinc? Okay, so there's a stoichiometry problem that's going to use molarity in it as a conversion factor. So I want to know how much is radioactive lead with 4 grams of zinc. So that's what my question is asking about. So 4 grams of zinc. So I'm going to go from zinc to how much HCl. So I'm going from one compound to another compound. So I need to use my balanced equation, which is in moles. So I need to use my molar mass. So I'll look up zinc in this periodic table, 65.4. So that'll give me my moles of zinc. So 1 mole of zinc. I want to go to HCl, so I use my balanced equation. 1 mole of zinc reacts with 2 moles of HCl. Put the mole of zinc on bottom, HCl on top, so it'll cancel. Now I know moles of HCl, I don't know what volume of this concentration, so this is moles per liter. Use that as a conversion factor. Now put the moles on bottom, it's moles per liter, put moles on bottom so it'll cancel out, and I'll be left with my answer in liters of that solution. So 4 times 2 divided by 65.4 divided by 0.3. 3 significant figures. I get 408.408 liters. In milliliters, that'd be 408 milliliters. So A, correct answer. So that is the review for the exam. So good luck, and I'll see you on Monday. Bye.